Hello YouTube, Poopslag here, and this is TurboFat, an open source puzzle game I'm developing in the Godot engine. You can find a link to the source code at the GitHub page in the description below. And this month I've mostly been focused on developing a suite of tutorials to teach players more advanced game mechanics like how the squish, move, and combo system works. That way when players pick up the game for the first time, if they're confused by it, they sort of know where to go for help and it'll teach them the basics. So let me show you what I've been doing. So when I thought about how I'd teach people to play, I imagined it going sort of three ways. The first extreme was letting them screw around and just sort of learn things on their own. And at the other extreme was having a bunch of diagrams and paragraphs for them to read, telling the concepts. And then maybe somewhere in the middle was sort of a show and tell approach, where the computer does something and then you try to copy it. I sort of went with a mix of the three for my tutorials. Fortunately, I had already covered a lot of this ground a few months ago for my one tutorial. So now all I had to do was modularize it so you could swap in different tutorial logic and extend its functionality a little. When you're making these sort of frameworks, I'm a strong proponent of what's called the last responsible moment principle, which is an agile concept where you concede that you're going to have to design something eventually, but you put it off as long as possible. In other words, rather than trying to plan ahead and figure out what framework my tutorial will need before I write it, I can just write one tutorial, and then when it comes time to write the second tutorial, I'll pull out the reusable bits out of the first one, and that becomes the framework. It's a lot easier than trying to plan ahead, and it reduces the chance of developing a lot of crap you're not going to use. So each of the three tutorial modules is in its own scene with its own script, and the script includes business logic. For example, here's some business logic for the first tutorial the player experiences, where it says the first time they make a box, it displays a special message and conditionally skips another part of the tutorial. So each module has its own business logic script. Each module also has this skill tally items node. This handles all the green rectangles that appear on the right, telling the player what they need to do next to continue in the tutorial. These UI items are copied into the tutorial HUD at the start of the tutorial. That logic is handled by this parent tutorial module script, which is the parent class for all of the tutorial modules. You can see here it looks through the child skill tally items node, gets all of its children, and adds them to the HUD. This parent class also has one or two other utility functions for things that the tutorials all have in common, like having a countdown where the tutorial music stops and some regular puzzle music replaces it. I anticipate this parent class becoming more complicated as I add more tutorials, or possibly over the coming week when I do some refactoring and pull out some common code. The combo tutorial required me to develop a replay system so that the computer can demonstrate some concepts for you by moving pieces around. I really couldn't think of a way to explain some of the more complex concepts to the player without this system. So the level data includes some replay JSON data, which includes a frame number, and an action name, which is triggered and then untriggered. I'd already abstracted out the input handlers into their own classes, so I just had to modify these input handlers to ignore player input if there's replay data available, and to instead process the data from the replay. This was something I put off doing because I thought it might take a few days, but because I already had this abstraction in place, it ended up just being an hour or two's worth of work. This abstraction wasn't a matter of foresight, it was just something I coincidentally needed to make the puzzle inputs work the way I wanted earlier, but I ended up being able to reuse that abstraction here. So lucky me. Developing the combo tutorial highlighted another problem with the game, which is that you really couldn't tell what your current combo was. Since I still had a couple days left until the end of the month, I decided to go ahead and tackle that as well. I developed this combo counter scene which had a few different parts to it, including a label that could show their current combo as it counted up, a little shape behind the current combo which could add emphasis when their combo got really big, and of course some particles because everything needs particles. And then I made this factory class which is responsible for instantiating those counters and positioning them appropriately. I added a little extra logic to make sure the combo counters never align vertically because I thought it helped them stand out and look a little cooler. The result looks pretty cool though. You can see as the player clears lines, those little numbers appear where their block was, and it counts up and the color changes. It feels a lot more rewarding building up a big combo. I also added this cute looking animated wallpaper. If we break it down, you can see it's sort of made up of three different things. The first is just these little animated stickers that wobble back and forth. They each go in front of their own little color rect. And those are separated by these sine wave border objects. Those are tiled texture rects with a custom image I drew. I went with an image in case I want to swap it out in the future, and maybe have a few different variations. For who knows what reason, I made the wallpaper change color based on the day of the week? I don't know, I was bored. So on Sundays, it's strawberry red. Tomorrow, if I play the game, it'll be brown, and it cycles through a bunch of different ones. One obstacle I didn't anticipate, though, is I of course wanted it so that when you change scenes from one scene to the other, the wallpaper looks like it's static. But since these are different scenes and the wallpaper is a child of each one, that's not trivial to accomplish. One approach might be to have the wallpaper be on some sort of a parent scene, and to have the various menus and puzzles all derive from that parent. But I didn't like how constraining that might be, as that parent scene might grow to become a huge blob class with 40 or 50 things in it. So I went with a different design. I assigned this wallpaper a new node group called the singletons group, and then I wrote a utility method which does two important things. The first thing it does is traverse the scene tree and find any nodes that are in the singletons group and store them in its internal cache here. This is what happens when you first start up the game. It adds that wallpaper node like normal, traverses the tree, finds the wallpaper node, and adds it to this internal singletons cache. However, the next time it loads a different scene, such as the main menu, it activates the other part of this if statement. This is where it sees that the cache already has an entry called wallpaper, and it swaps out the wallpaper node in the scene tree with the one from the cache. The result is that as far as the player is concerned, it looks pretty seamless. Behind the scenes, as a programmer, I know it's creating an extra copy of this wallpaper and then throwing it away, and that's maybe a little icky. But what the player doesn't know can't hurt them, right? Maybe someday if there's some sort of a performance bottleneck or hiccup, I'll see if I can come up with a slightly cleaner design. There's 2 new music tracks this month, courtesy of Pete Ellison of Disco Warp Records, entitled Dessert Course with No Name and Harder, Butter, Fatter, Stronger. I thought these titles were hilarious, but they were never displayed in the game. So I added something Pete had suggested a while ago, a little toaster pop-up which shows you which song's playing. Every time the song changes, it just pops down from the top briefly, displays the song title, and then disappears again. This way, if the player hears a song they really like, they have a way to Google it. So I noticed a little performance hiccup where the game would drop a few frames every time it had to load a new creature. This is especially prominent on the faster difficulty levels where dropping a few frames could really affect your gameplay. I eventually traced the bottleneck to the part of the code where it takes the creature's DNA and tries to update their appearance by loading a new set of textures and setting a bunch of shader properties. A creature has about 40 different nodes and about 200 or so different properties, so setting all these at once could take a few milliseconds. The first thing I attempted was multi-threading the code, just running it in a background thread. This worked okay on my PC, but on everyone else's computers they encountered tons of bugs, where different body parts wouldn't be loaded, colors would be wrong, which makes total sense. After all, what would happen if it tried to play an animation and the creature's texture hadn't been loaded, or was loaded in the middle of the animation? I started trying to fix these bugs with a complex system of semaphores, where the creature's animations would all be locked until all their properties were set, and then they'd get unlocked later. But I ended up abandoning it. The threaded approach was just too difficult, and I thought of something better. So the next thing I noticed was that a lot of these properties were really fast to set, and others had to crunch for a little while, specifically the shader keys. Things like saying this creature has green ears or red eyes, and updating the shader properties, that always took a couple milliseconds. So I ended up deferring all those shader properties into a queue, and then I load a couple of those every frame. Basically, I'll set 1 or 2, and then I'll check whether too much time has elapsed, and once it gets over 240 microseconds, I'll skip to the next frame and defer the rest of the shader keys for later. This worked great, and I would say got rid of about 60% of the jitter, but I thought I could do a tiny bit better. The last bottleneck I noticed was parsing the JSON for these ASCII packed sprites. In order to load these packed textures, it has to parse this JSON file describing where in the picture each of the frames is. And parsing a JSON file is pretty fast, but it's not the kind of thing you want to do 40 times in a single frame. So the workaround I came up with is that when the game first starts up, it finds all the JSON resource paths in the game and checks if they contain any ASCII frame data. If they do, it loads that frame data and stores it in a cache. This way later, if a creature needs to be initialized with a specific kind of ear and mouth, rather than loading all those different JSON files, it just needs to come here for the cached data from that file. It's a constant time lookup instead of an expensive JSON parse operation. This makes the creature loading way faster. I can't notice any performance hiccup at all anymore. It's really smooth. As usual, there's a bunch of new creature parts this month too. So now you can have a little lizard tail, some little orc ears, or goblin ears, spooky skeleton eyes, and a few other things. I don't know if it was because of Halloween or what, but it definitely felt like the community's ideas had a bit of a theme this month. Overall though, the Discord community's been invaluable as far as giving me feedback, helping me track down bugs, create new characters, and giving feedback for things like which fonts look better. Overall, it's just relaxing letting the game have a voice that's not 100% my own, you know? Getting to fall back on other people and their ideas a little bit. Look at this little guy. What the heck? So yeah, that's where we're at as of the start of November. I was sort of hoping to get to some of the cool level ideas I had and stuff, because honestly, that's sort of the fun part. But it did seem like it was more important to get the tutorials and onboarding in place so that I can start showing this game off to my friends and having them try it out. It was just a little bit too impenetrable in its older state, where you really had to dig around on a wiki to do a lot of experimentation to understand the mechanics. With the tutorials in place, I think it's a lot more accessible, a lot more playable. They should be on board now. But next month I want to get to where there's a bit more of a story, and the overworld, the place where you walk around, actually has like a coherent, like, oh, this is a location, there's people you can talk to, and stuff that happens, you know, just feeling a little bit more complete, so I can sort of figure out how much work that's going to be, because I know it's going to be an ass load, but I just got to figure out how much, and we'll see what I can knock out in a month, right? Anyway, see you guys in a month. Thanks for watching.